So its projection on the floor, is OR. OR is the projection on the floor, okay, and you can say it is a projection vector. Similarly, you may have the projection on this corner. See. So I hope that you can visualize a space vector or a vector in 3-dimensional space, okay, and this OP can be written as xi plus yj plus zk. So my dear friends, you might have understood the vector in a various dimension, 2-dimension and 3-dimension. So any point can be represented as the position vector, okay, and now let us have the idea about the 2-dimensional vector and 3-dimensional vector. You can see it on the screen in a colorful manner, 2-dimensional and 3-dimensional vector, okay. So here I would like to draw the attention why we are using the vector. So vector is, you can say, the somewhat more modern form of our ordinary numbers, ordinary algebra, okay. Initially number were manipulated, some operations were used, or operations were operated on the numbers and variables. Now with the advancement of science and technology, we had to revise our concept, and that concept is revised and revised to the vector, okay. So when you are talking about the algebra or vector algebra, you must have to establish the mathematical formation of addition, subtraction, multiplication and division. So here the division is not there in the algebra, in this our new algebra, vector algebra. It has no concept of division, but here we have the simple concept of addition and multiplication. Again I would like to draw your attention to the word multiplication. When we talk about the multiplication, this is merely the simple, our ordinary multiplication with one number to another number, or you can say it's a simple multiplication between two scalars, okay. But when we talk about the vectors, you cannot use the word multiplication, because it's not only the numbers, it has something different. It has something different idea than our ordinary numbers, or you can say the scalars. So that is why we cannot use the word multiplication for two vectors. In that case, we use the word product of two vectors. So that is the correct and perfect word, or you can say it is a technical word, product between two vectors. We cannot use the word multiplication. Multiplication between two vectors should not be used, okay. So this is just the product, how we get the product. But before that, let us have the idea about the addition and subtraction, okay. So now look at the screen. I have given a simple example. For addition and subtraction, we add or subtract the corresponding values of the vectors. That means the corresponding value of the tuple. Tuple means xy tuple, xyz tuple. So suppose we have two vectors and its position values are x1, y1, z1, and another vector x2, y2 and z2. So here we add or subtract the corresponding value x1 minus x2, y1 minus y2 and z1 minus z2, okay. So again you look at this screen, we have two vectors capital A and capital B, that is capital A is equal to 3i plus 2j plus k, and B is equal to I minus 3j plus 2k. Okay, so I, j, k are the unit vectors along x, y and z axis. So their resolution, you can say here the 3i or 3 is the resolution along the x axis, so we call it 3i. 2 unit means 2 unit is the resolution along the y axis, so we call it 2j, and k into 1 or 1 into k, so we can say it is a 1 unit of resolution along the z axis. That is why 3i plus 2j plus k is a vector. Okay, or you can say it is a position vector. Now instead of position vector, I will use the word only the vector A and vector B. That means I want to say vector A and B are the position vectors. So another vector B is I minus 3j plus 2k. Okay, the concept is the just same as the vector A. So when we want to add two vectors A plus B, that means we are adding the corresponding resolution along x, y and z axis. Okay, so you never so you should never forget the corresponding values. Okay, it's just a concept, you are adding the corresponding values. Okay, so for vector A and B, we are adding the corresponding resolution along x axis, and that is 3 and 1, and we call it 3 and 1 means adding 3 and 1 is 4. So 4i adding 2 and minus 3, so this is minus 1, so it is minus j. We are adding 1k and 2k, that is 1 plus 2, that is 3, so it is 3k. So when we add, we are adding the corresponding value, though they are certain resolutions are negative, we are adding them with respect to its position. Okay, similarly the subtraction of two vectors A minus B, okay, and this is simply the subtraction between the corresponding resolution of x, y and z, and that is 3i minus I, that is 2i, 2j minus the minus value, negative value of the j resolution, y resolution, that is minus plus, and 2 plus 3 is 5k, and k minus 2k, that is simple minus k. So these are the addition and subtraction of two vectors. Okay, so you can see now the addition of two vectors, the geometrical meaning of adding a two vectors. Suppose we have two vectors on a plane, you can see that their triangle, it is one triangle is formed for A and B, and the another third side is the addition of A and B. So I would like to draw the attention, look at the paper. Suppose I have one vector, that is A, this is the origin, I call it A, vector A. Okay, suppose I have another vector B, this is B. So we have two vectors A and B. So you can see the angle between A and B is suppose theta. Okay, so here it is starting from this origin of the vector A, or we want to add some another vector A, suppose this is vector B. Okay, to adding these two different vectors, so let us make them concurrent, or I can say that these vectors must be parallelly shifted. So I want to shift that vector parallel. Okay, and I bring it to this position, and this will be equal magnitude and the same direction. I am not changing the direction of A, and I am not changing the direction of B over here, but I am changing its relative position to the end point of the vector A. So now I am joining end point of A and starting point of B. Okay. So addition of these two vectors. So you can see this direction here, the same direction, or means you can say it is a anti-clockwise direction. So the addition of these two vectors is given by another vector, and we call it A plus B. Okay. So look at this. This is the geometrical meaning of addition of two vectors. Okay. Even this can be performed as, suppose we have two vectors A, B, we can use parallelogram. Okay, we can use the parallelogram. So this is A plus B. So you can say that it is a shifted to this position, and ultimately we get another join. You can say the starting or end point of A, or starting or and end point of B. So this is A plus B. These are the different geometrical representation of the addition of two vector. Okay. Now unit vector. Suppose I have a vector A, okay, and it is represented as xi plus yj plus zk. This is the vector. So I want to find the unit vector along the given vector A. Then it is defined as unit vector A bar upon the modulus A bar. This is the unit vector. This is unit vector along the vector A. Okay. Now what is modulus A? What is this? Okay. The modulus A is nothing but the x square plus y square plus z square. Okay. This is the modulus of the vector A, and this is square of the resolution along x, y and z axis, square of the resolution along x, y and z axis, and they are adding. So why we call it a modulus, or something you can tell, you can say that it is the distance, or you can say it is OP. Okay, you can say it is OP. Sorry, let me explain. Suppose we have three-dimensional space. This is P, X, Y and Z. This is OP. Okay, this is OP. Now I want to find the value of OP. I want OP. Okay. For that I must have the projection on the floor, as I told you. Okay. So we know that this point, let me use R. So here PR is perpendicular to OR. Got it? Have you got this? This is floor. This portion is floor. Okay. This point is on the space, in the space. Okay. So on the floor and in the space. So you can say that this is right angle. This is 90 degree. I hope that you are visualizing this as a 90 degree. So these are the perpendicular vectors. So now we have a triangle, or you can say that this is the right angle triangle, and OP is the hypotenuse. You can say it is a OP. OP is hypotenuse. Okay. So this height, and this is Z. Okay, this is Z. This is Z axis, X axis, and Y axis. So this is Z. So now let me drop a perpendicular on X axis. Okay. So I can use this Z and this form. So this is X, this portion is Y, and this portion is Z. Okay. So this value is X square plus Y square. Sorry, this is equal to Y. So this value is, this portion is X square plus Y square under root. We are using the Pythagoras rule. Okay. Now we want find the value of OP. Okay. So when we talk about this figure or this triangle, we can write that OP is equal to under root X square plus Y square plus Z square. Okay. So that is why we call that the resolution, or call that the value of OP, that is under root X square plus Y square plus Z square. Okay. So for the unit vector, look at this. This is our unit vector. Unit vector is nothing but the vector itself upon the modulus of the given vector. Okay, that is our unit vector. So unit vector of A is equal to xi plus yj plus zk upon underscore x square plus y square plus z square under the root of x square plus y square and z square. Okay. So let us find, suppose we have some vector A is equal to 3i plus